Welcome to Brain Vision.
For this problem on the topic of DC circuits, we are given a 12-volt battery which is connected to two resistors in series, as in the diagram. A voltmeter, whose internal resistance is given, measures the voltage across each resistor when it is connected across each one. We want to find the resistance of each of these resistors. So we'll firstly draw two diagrams, and on the left we'll connect the voltmeter across the first resistor, and on the right in diagram 2 we'll connect the voltmeter across resistor 2. Now we can find our currents, and we'll first look at diagram 1. So we know the current I1 is equal to the current in the branches I1A plus I1V. So the current across the resistor plus the current across the voltmeter gives us the total current, or the maximum current, I1. So we can also use our loop rule, and we see that epsilon minus VR1 minus I1 R2 is equal to 0. This implies that the current I1 can be written as the EMF epsilon minus VR1 over R2. Now the current I1A is equal to the voltage measured across R1 VR1 divided by the resistance R1. The current that flows through the voltmeter I1V is equal to the voltage across the voltmeter V1V over the resistance of the internal resistance of the voltmeter RV. So from here we can see that epsilon minus V R1 over R2 is equal to V R1 over R1 plus V1V over RV. So now we'll do the same for the second diagram. For diagram 2, we can see again that I2, the current I2, is equal to I2A plus I2V. And again, epsilon minus I2 R1 minus V R2 must equal to 0. And this implies that the current I2 can be written as epsilon minus VR2 divided by R1. And similarly, we can find I2A, as we did above, to be VR2 over the resistance R2. The current across the voltmeter I2V is equal to V2V divided by the internal resistance of the voltmeter RV. And so again, like above, we get an expression epsilon minus VR2 over R1 is equal to VR2 over R2 plus V2V over RV. So now we can see there are two equations with the two unknowns R1 and R2. So if we substitute our values in here, we can find these two resistances. So if we assume that all the resistances are measured in kilo ohms, we have from equation 1 epsilon minus VR1 divided by R2 is equal to V R1 over R1 plus V1V over RV. And if we put our values into this, this becomes 12 minus 5.5. So the EMF is 12 divided by R2, which is unknown, is equal to 5.5 over R1 plus 5.5 over RV, which is 18. And so if we rearrange this equation and simplify, we get 6.5 over R2 is equal to 5.5 over R1 plus 0.30556. So we'll call this equation 1. Here we have one equation with two unknowns, R1 and R2. Now we'll do the same for the second of the two equations. And we have epsilon minus VR2 divided by R1 is equal to VR2 over R2 plus V2V over RV. And if we put our values into this, we get 12 volts minus 4 volts divided by R1 must equal 4 over R2 plus 4 over 18. And so simplifying this, we get 8 over R1 must equal to 4 over R2 plus 0.22222. And we can call this equation 2. So we have yet another equation with the two unknowns R1 and R2. So now, if we solve these two equations simultaneously, we can find the two resistances. So if we solve equation 1 and 2, we get the resistance R1 to be 11 kilo ohms and the resistance of R2 to be 8.2 kilo ohms.